Alright, this is a fairly complicated problem. This is number 40. You have an Atwood machine, you have mass 1 here, mass 2 here, and you have this solid disk with a radius and a mass also. They've given us the masses of the block 1 and block 2. They've also given us the mass of the wheel that's spinning, and they've given us its radius. A asks us to construct separate force diagrams for block 1 and 2. So if you look at the force diagrams, you have tension going up, and you have mass times gravity going down, and that's for both of these. I did the same thing for the wheel, and you have the force of the axle on this pulley, and then you have T1 here and T2 there. So these two equal that one at this point. Next, for B, it says to determine the rotation inertia of the pulley. Since this is a solid disc, I is equal to 1/2 mr squared, and so we plug in its value and we get that right there. That's B. Now for C. C asks us to use the force diagrams for block 1 and 2 and Newton's second law to write expression relating the unknown acceleration of the block. So here's what we got to do. It says Newton's law, we got sum of the forces equals mass times acceleration. So when we sum the forces on block 1 and 2, we get this m1 times g minus t1 equals m1 times a, and we do the same thing on the other side. And you'll notice that I have the negatives and positives, and they are based on which direction that these tensions spin the pulley. So pause it and look at that to make sure you understand what's going on there. It's just rotation. Clockwise is negative, counterclockwise is positive. For D, D gets a little complicated. D has, so with D, what they want us to do is use the pulley force diagram and the rotational form of Newton's second law to write an expression for the rotational acceleration of the pulley. This is the part of Newton's laws they're talking about. We have alpha equals 1 over I times the sum of the torques. I manipulate this for sum of the torques. I get sum of the torques equals I alpha. When I sum up the torques, you'll see that I have T1 times radius minus T2 times radius. Again, the negative sign is because it rotates it clockwise, and that's what T2 does to this pulley. And then it's equal to I alpha. I, we have already figured out for a solid disk, is 1/2 mr squared times alpha. I manipulate this guy. I get this alpha here that I didn't really know what to do with, and so what I did is I went back and looked in our book, and I get acceleration tangential equals r alpha, and I manipulate that for alpha. Alpha is equal to AT over r. I plug that stuff in. I'm able to get rid of the r's. I'm able to factor out the r and then get rid of them. I'm able to combine some terms, and I just come up with this equation: T1 minus T2 equals 1/2 m times AT. And that's about as far as I could get with that. Wasn't really sure if that was enough, but it seemed to work out later. So now, E says, noting that acceleration is r alpha, and I have that right there. For the pulley, use the 3 equation from parts C and D to determine the magnitude of the acceleration of the hanging blocks. So if you remember from block 1, we had this equation right here, and we already wrote that down. And what I did is I just manipulated it to get T1, and for block 2 I manipulated to get T2. The pulley is that equation we just figured out in D, and there it is written again. So what they want us to do is if you notice, I have T1 equals this, I have T2 equals that, and I have T1 and T2 in this pulley equation. Well, what I did is I just substituted these two into this equation. And then you'll notice what I did is I tried to get the accelerations, the things with a in them, which is m1 times a and m2 times a, tried to get them over to the right side of the equation, because I also had a over here. And I have acceleration in 3 different spots. Once I get all 3 of the pieces that have acceleration in them over to the right, I factored out acceleration. On the other side, I factored out gravity. And so then when I got acceleration by itself, I divided both sides by this. I have the masses of everything. They go on the bottom. I plug everything in. I get an acceleration of 0.643 meters per second squared. That's a crazy problem, a little difficult, but if you just kind of go through each little step, it shouldn't be too difficult.